In a reverted epicyclic gear train, the arm A carries two gear B and C on one side, then the compound gear D and E on other side. Student, please remember you have to draw this diagram. The diagram is not given. So you must be very careful while drawing this diagram. If you make any mistake on this diagram, then the entire problem will go wrong. The gear B messes with gear E. Here, the gear B messes with gear E, which means B larger gear, E smaller gear. Then gear C messes with gear D. Already we know that DE is a compound gear, D outer gear, E inner gear, which means D larger gear, D meshes with C, which means C smaller gear. The number of teeth on gear B, C, D are TB 75, TC 30, TD 90. We need to find the speed and direction of gear C when gear B is fixed and O makes 100 RPM. There are four gears B, C, D, E, but we know only the number of teeth on three gears. So we need to find out the number of teeth on unknown gear, that is E. We can find this using a relation. Let me tell you the relation. RB, radius of gear B plus radius of gear E. I can write it like this, equal to radius of gear C plus radius of gear B. These two things are equal. Multiply both sides by 2. 2 times of radius equal to diameter. I can write it as TB plus TE equal to TC plus TD. Here D represents diameter of gear. We know that M equal to diameter divided by teeth. Module constant. From that T equal to directly proportional to B. So I can replace this relation as TB plus TE equal to TC plus TD. TB 75, TC 30, TD 90. Replace these values. Now you will get TE equal to 45. Now I'm going to use a tabular form to find the speed of unknown gear. The table contains condition and revolution. Arm fixed, we have to give +1 rotation to DE. There is a reason why we are giving +1 rotation to DE. We need to find speed of C value, so I can't use C in the first column. That is why we are using DE. Row 2, same, similar to row 1. The only difference is we are giving plus X rotation instead of +1 rotation. Arm fixed, we are giving plus X rotation to DE. Then add Y revolution, then finally total. Usually, the reverted gear train or the epicyclic gear train has relative motion. Relative motion means two uh, parameters will move at a time. It will be very difficult to find the solution. That is why we are first fixing arm, giving +1 rotation to DE, then we are giving Y revolution to arm. Then we are adding these two. So this is a logic behind tabular form. Now we have to find the column. Column 1, arm. Since arm fixed, we use arm A as column 1. Column 2, after fixing arm, we are giving +1 rotation to DE. So DE will be considered as column 2. D connected with E connected with B. So after DE, we can use B. Then B connected with C. So finally, C will come. Next, we have to find the revolution. Here, the revolution indicates speed. N. Arm fixed means speed of revolution of arm A 0. Then we are giving plus 1 rotation. Here, the plus 1 rotation represent counterclockwise. Next, we need to find speed of gear B. NB divided by NB touches with NE. So NB divided by NE equal to reverse TE divided by TB. That's what we are writing. DE divided by TB. Here, the minus sign indicates the gear B and the gear E both are having external contact. External contact means when B rotates clockwise, E rotates anti-clockwise. So that is the meaning. That is why we are putting minus sign here. So this is minus. Next, we need to find out the speed of gear C, NC. So NC equal to the gear C touches with gear D. So NC divided by ND equal to TD divided by TC. Again, here ND and NE both are 1. So NC equal to TD divided by TC into 1. So this is TD divided by TC. Now, what is the speed of, what is the direction of gear C? C and B both are same direction because both are connected on same shaft. We already know the direction of B. Direction of B minus, which means direction of C also minus. So you must be very careful on choosing the direction of gear. When two gears contact externally, we use minus sign. If it is minus, then plus. If it is plus, then minus. If two gears contact internally, then whatever the sign we already have, that will be repeated. If it is plus, then plus will come. If it is minus, then minus will come. But for external contact, plus means minus, minus means plus. So this is how we identify the direction. Now coming to second row. So what is the difference between second row and first row? Same thing. Only thing is we are multiplying with x. 0 into x, 0. 1 into x, x. Minus te by tb into x, minus x te by tb. Then finally minus x td by tc. Then we are adding y revolution to all the gear. Then finally we need to add 2 and 3. Student, this is very important. You should not add 1, 2, 3. You have to add only 2 and 3. 1 and 2 both are same. Only thing is we are giving plus x rotation. So finally we have to add 2 and 3. When you add 2 and 3, column row 2 and row 3, you will get y, x plus, here it is x plus y minus x t by tb, then y minus x td by tc. Now we need to find out the speed of gear C, because problem statement says that find the speed of gear C where B is fixed, which means speed of gear B equal to 0 and arm A makes 100 RPM clockwise. Clockwise means minus, counterclockwise means plus. This is what we are using. Let us take these parameters to table. ND equal to 0, which means y minus x t by tb equal to 0. Again, y equal to minus 100. Then te 45, tb 75. You will get x equal to minus 166.67. Now I can substitute this x and y value. This is x and this is y on NC. This is what we need to find. NC equal to y minus x TD by TC, y minus 100 x 166.67. You will get 400 RPM. Here the plus sign represent counterclockwise. Minus means clockwise. So finally, the gear C makes 400 RPM in counterclockwise direction.